morning. Okay, lesson 3.2, we have 2 learning goals today. These are the 2 things we have to make sure that we understand in this lesson. Being able to identify domain and range, and being able to determine if a relation is a function. Okay, if you would like a highlighter for these notes, get your hand up, I'll pass it back. Okay, so what do we have of you? 2, 4, 5, 6, I think. And a couple of them. Okay. So what we're going to do is we're going to pay attention, really close attention to at the top here, that there's some vocabulary words that we need to make sure we understand. A relation, what is a relation? It is any set of ordered pairs. A relation is a set of ordered pairs. The relation can be given as a set of ordered pairs, or it can also be given as a table, as a graph, as a mapping diagram, and we're going to talk about all 3 of those. Another key vocabulary word is, what is a domain? Well, a domain are all those x values of those ordered pairs in the relation. So all the x values of the ordered pairs in the relation make up the domain. And then what's the range? Well, the range is the other value of the ordered pair, the y value. So the range is made up of all the y values of those ordered pairs. And I don't want to see that one either. Okay, so find the domain and range. Here we have a table. How many ordered pairs are being represented in that table? 4. There's 4 of them. We have ordered pair 3, 1. We have ordered pairs, so they could be written like this: 3, 1, 4, 2, 5, 2, 6, 3. So that's our relation. It's a set of ordered pairs, but written in table form, and always in table form. The x and the y values correspond with each other. They stay together as pairs. You can tell that they are an ordered pair. So when we write the domain and the range for that, what we do is we pick all the x values from those ordered pairs, and we use set notation. So it's going to be really important that we practice that. Set notation. And we are going to put them going from least to greatest, even if that's not the order they're in the table, even if that's not the order they're in the list, the mapping diagram, whatever. We're going to put them in order from least to greatest, which they already did, so we can say, you know what, that looks good. We have x values 3, 4, 5, and 6. Parentheses are reserved for ordered pairs. Do not make parentheses for set notation. Capital D gets to represent domain. You do not have to write out the word domain. Same thing goes for range. Set notation. Y values from least to greatest. But there are 4 y values. Why are there only 3 in this range? Amber?
We don't want to list 2 twice.
Yeah, we don't want to list 2 twice. We do not do any repeating. So we only list the values 1 time. So notice, once we've written them in set notation as domain and range, now we can no longer see their relationships as ordered pairs. Now we're saying, here are all the x values, here are all the y values. When we do it in a map, we're going to make our maps different, so we're going to do it right now. The first oval is always the x values, the domain, and the other oval is always the y values, the range. And in reality, our mapping diagram should look like our set notation for when we're writing it out as domain and range. We're going to take the x values and we're going to do them from least to greatest. Same thing with our range values. They already are least to greatest, so we don't have to switch that one around. So even though this is how the book might do it, we're going to do the typical way, which is list them from least to greatest. The map gets a little messier this way. How many ordered pairs are represented in this one? 4. And do we know what they are? What are the ordered pairs? Give me an ordered pair from this relation. Tessa?
2, 6.
2, 6. Oh, I don't think so. 2 goes with 7, it's mapped to 7, so that would be ordered pair 2, 7. The one that has 6 for a Y value is 5, it would be ordered pair 5, 6. So how many ordered pairs do we have? 4. 1, 2, 3, 4. Okay.
We have a white Durango in the north staff parking lot that needs to be moved, please.
So I'm remapping here because now they no longer line up straight across from each other. So you need to do a new map. You need to map the X value to the Y value. Map the X values to the Y value to show their relationship to each other so that you could write ordered pairs from it if you were asked to. And then for domain and range, we don't like the order that they did the domain in. We're going to switch it up. It's going to go from least to greatest, just like it does in our mapping diagram. We just have to copy that. 2 or 0, not 2. Let me start with 2. 0, 2, 5, 7. And our range is going to be the order that they did it, the order that it's in our mapping diagram as. So this is what I'm going to hold you accountable for when I talk about accuracy points in homework. When you're doing your homework, this is what I expect. Set notation, when you're supposed to get the domain and range, least to greatest, do not do any repeats. So when I circle problems and say redo, you got to figure out what did you not do right in that one. Questions so far? If we graph both of those first two, what kind of a graph would they give us? Do you think a discrete or a continuous? Discrete. They are distinct points. It would be a discrete graph. What's this one over here now, our third one that we're going to find the domain and range for? What kind of a relation is this? It's continuous because we can't begin to name all of the points that are on that line segment represented on that graph. It's continuous. There are not just whole number distinct points, or we have so many ordered pairs on there. So when we have a continuous graph, we are not going to be able to make a list of X values and a list of Y values. We're going to have to do inequality statements. So what we're going to do is, this one ends here, and it ends at that other end also. So we're going to name those endpoints. What's the ordered pair name for that top one?
5, 2. 2, 5.
2, 5. The X value always comes first, followed by the Y value. What's the ordered pair name for the bottom one?
7, 3.
7, 3. Ordered pair 7, 3. So remember, the domain is made up of X values. So we included in this domain are not just 2 and 7, but all those points on that line segment between that. So we are going to talk about our domain being, we're going to add some set notation here. Our domain starts at 2, ends at 7, and notice it's an and compound inequality. Remember our graphs for compound inequalities? Were they not typically between 2 endpoints? They were shading between 2 endpoints. So we have to write a compound inequality for this. So the domain values start at 2 and they end at 7. So those are our endpoints. You can think of this as a kind of like a graph for a compound inequality. Our range starts at 3 and goes up to 5. Range is from 3 to 5, so we do the same thing. We write a compound inequality, but notice what's different about that compound inequality has a different variable, because what is the range made up of? It's not made up of x's, it's made up of y. So we have to make sure we use a y in our inequality statement for that. Okay, so we'll be doing some practice of this. Let's go down here and start practicing. Find the domain and the range of each relation. So here's our first one. It's in table form. How many ordered pairs are there in this relation? 4. Okay. Let's get its domain. Capital D, set notation. What's it going to start with?
-2.
Followed by?
-1.
-1. 0. 1. Okay. There's no repeats going on in that one. It was already in order from least to greatest. That was pretty easy to do. Range. What's our range gonna start with?
0,
0, followed by,
1,
followed by,
4,
followed by?
4.
No.
Set notation.
Set notation, we're not gonna repeat that 4. We do not, if a value is used more than once, it only needs to be counted 4 once in there. Okay, how about number 2?
4,
Nope.
negative 5.
-5.
I went to number 3. My
Oh,
bad.
did you? Okay,
I
well,
thought you were asking how many there were.
okay. Next one is, the domain's gonna start at -5. What's its next domain value? -2, followed by 4. There are only 3 ordered pairs. There are 3 different x values, so there are 3 members in our domain. How about our range? 5, 6, 12. Okay. So notice, once we write it in our set notation, we lose the relationship. We cannot say that these guys are an ordered pair, because they aren't, are they? No, they're not an ordered pair. So we lose, you don't see the relationship when it's written in set notation as domain and range. The only time we can see the relationship is in a table, or if they're written as a set of ordered pairs, or in a mapping diagram. So let's look at this one. Even though this mapping diagram wasn't made the way you're gonna make them, we can still give the domain. What would the domain be? 0, 2, 3. Range, 5, 6, 7, 8. We're gonna switch up that order. And when we make a diagram, we would switch up that order also.
So you want us to make a diagram in our homework?
Yeah, if they ask you to make a mapping diagram, then this is what it would look like, a mapping diagram, except we would switch this up so that it would go from 5 through 8, and then we would map our arrows
So if the question is wrong, do we have to fix it?
in the book. Yes, yeah. Mhm. Okay, number 4. What's the domain?
Negative 3.
-5, -4, -3. Did they make that the way we're gonna make them? No. The range.
10,
10, 11, 12 is already in order. And 13. How many ordered pairs are in this one?
3.
4.
Yeah.
Yeah, because x is used twice when the x is what? -4. When x is -4, we have ordered pair -4, 11, and we have ordered pair -4, 12. So we have 4 ordered pairs represented here. And we should be able to say that because we have 4 arrows. Every x value gets mapped to a y value, okay? Okay, number 5, we have a continuous. What do we have to do when we have a continuous? Can we write every x value? Can we write every y value?
No.
Absolutely not. Don't even attempt to, because you won't be able to do it. So here's what you should do instead. Name those endpoints. If there are endpoints, name them. What's the bottom one?
-2.
Okay. What's the top one?
2, 4.
2, 4. Okay. Our domain.
-2 is less than or equal to x.
-2 is less than or equal to 2. Between the two x values of the endpoints, including the endpoints. That's right, we have the equal to bar there. So an and compound inequality that shows any point you pick on that line has an x value from -2 to +2 inclusive. Okay, range. What would that look like? 1,
Less than or equal to
x,
Y.
y. The range is made up of y's. Is less than or equal to 4. The y values lie between 1 and 4 inclusive. any point on that line segment. So we got y values like 1.3694. We have y values like 1.8736679. I mean, how do we even begin to name them all? We can't. That's why we have to write it as an inequality. Okay, how about number 6? What kind of a graph is this? Continuous. Think of it like this. If you can't name every ordered pair, it's continuous. So how are we going to do this one? Does it have endpoints?
Yeah.
What are they?
Four corners.
The 4 corners. Yeah, we're going to have to name the 4 corners. So go ahead and do that. And then after you've done that, go ahead and write the domain and the range. Let's see how you do. Write the domain and the range for this continuous relation. Okay, who's got the domain for me? Gotta read it, you have it? Okay, what is it? -3 what? 2? No, we don't use the word 2 in here. We make it into a compound inequality. Okay, Amber, do you want to finish it for us?
-3 is greater than or equal to x, and then greater than or equal to 2.
You all agree with her? X, okay, it says -3 is greater than all the x values. So -3, is -3 greater than all of these guys? No. So what do we have to do? We gotta flip that sign around, don't we? Both of those signs around? So is less than or equal to. For our ends, start with the smallest endpoint at one end, the largest at the other end. Is less than symbols, not is greater than. Okay? How about the range? Who's got that one for us? Person?
1 is less than or equal to y. Y is less than or equal to 3.
Okay, do you agree with that? Is that our range for this one? Doesn't go any lower, the y values on that, on that rectangle do not go any lower than 1, they do not go any higher than 3, and they're anywhere in between the sides, right? Okay, questions on domain and range? Okay, then let's go to the backside, and on the backside we're going to start creating showing the different displays that we can have relations displayed in. Anybody need this longer? I don't think I saw a hand. Okay, let's go back here and let's start with looking at the examples that they have for us. Oh, here's another key word. We need to do some more, this isn't the one where we start making the ones. I'm sorry, that's the next page. We are going to start talking about our other vocabulary word function, and this challenges students. If they keep getting their papers back on these, it's because they have not made a good, they have not figured out what a function really is. So a function is a type of relation, so it's a relation, a set of ordered pairs, where each x value, the domain, can be paired with only one y value, the range. So when you have an x value in the domain, it can only be paired up with exactly one y value in the range. You can't have more than one y value. So let's look at this table here. They say this table represents a function, and I think this table is actually this graph, so I think we could kind of combine these and show, because I think it's kind of important for us to see. We get to see a picture of that table, which also helps us see why this is a function. So why is this a function? We have x value 2. Does it have more than one y value? What's its y value? 3. We have x value 3. Does it have more than one y value?
Yep.
What is it? 4. What's its other y value?
6.
Really? Where do you
No,
see 3, 6 in that table?
there is.
When x was 2, I only saw one y value because there's no other x equals 2. Here, when x is equal to 3, this is the only time x is equal to 3, so it has exactly one y value. How about right here? When x is 4, does it have only one y value? No, it doesn't. It only has 1. It would only be mapped to 1. Just because 3 also has a y value of 4, it doesn't matter. 3 has a y value of 4, 4 has a y value of 4. They are separate x values and they each only have one y value. It doesn't matter that it's the same y value. This is where the definition gets tricky. Each x value can only have one y value. When x is 3, it has a y value of 4. It doesn't have any other y values. When x is 4, it only has one y value, 4. It doesn't have any other y values. When x is 5, it only has one y value, 6. It only has one y value. That's why this is a function. And look at the graph. How can we tell on the graph that it's a function? How does a graph give it away? That each x value has only one y value. Carson?
Because there's only a single dot on each x value.
There's only a single dot on each x value. If, let's just say there was another x value of 3 and its y value was 1, we could see right now that these 2 points share the same x value, but they have different y values. So now this would no longer be a function. But so basically what you would look for is you would say, are there any other points above or below that point that shares the same x value? Because if there are, I don't have a function anymore. And then let's look at our mapping diagram. This is another relation. Each x value has how many arrows coming out from it? No, each x value has how many arrows coming out from it? Just one. 2 has this one, 7 has this one, 8 has this one, 15 has that one. They each only have one. So do they each only have one y value? Yes, each x value has only one y value. Carter?
So there is allowed to be more than, like, 2 y values can be on the same line, but 2 x values can't.
That's right. So we can have a horizontal relationship. There can be more than one point on a horizontal part of the graph, but there cannot be more than one on the vertical. Any vertical, if you have more than one, that means you have an x value that has 2 or more different y values. Okay? Any other questions? Let's look at the not a functions one right here. We have this table, which does not go with this graph, by the way. We have this table, and look at right here. When x is 6, what's true? It's paired up with 2 different y values. It has 2 different y values. It doesn't just have one. Look at our graph. What's true when x is 3? 2 different y values. Let's look at our mapping diagram. Which one breaks the rule on that one? -6, right here. -6 is mapped to 2 different y values, so that makes it not a function. So all functions are relations. They come from the relation family. But not all relations are functions. We just saw 3 of them that are not. So all relations have to be tested to see if they're a function. They have to pass the function vocabulary test. Okay, let's practice then. Number 7. Is this a function, this table?
No.
Why not?
It has 2 x values that are the same.
Okay, but that doesn't matter. What matters?
Has 2 x values that have different y values.
It has an x value that has
2.
2 y values. That's why. So we're going to say, and I'm going to be fussy on this, how you state it. You cannot, so let's just get used to it right away from the beginning. This is not a function. X value, -3, has 2 different y values. It can only have one y value. It has two different y values. It would be mapped to 2, it would be mapped to 3. It can't be mapped to two y values. How about number 8? What do you think? You think that one's a function?
Yeah.
Okay, why?
Because each x value has one y value.
Each x value has only one y value, and here's how you can tell. Coming out from 4, there's only one arrow. Coming out from 8, there's only one arrow. It doesn't matter that they both have 5 as a y value. We could care less about that. They each only have one y value. 12 is mapped to just 1. 16 is mapped to just 1. So this is a function, and we state it like this. Each x value has only, I'm going to start to write the word 1 too, only one y value. Each x value has only one y value. That's how we have to state it. So if domain and range don't challenge students near as much as determining if a relation is a function or not. So do you have any questions here before we move on? We'll keep practicing the function thing on this last page, but. No? Okay, let's go to the last page where we're going to start displaying relations in table form, graph form, mapping form. Are you number 9? Oh, we have a number 9, thank you. Yeah, this is an important one to do. What do you think, is that one a function?
No.
Why not?
There's a bunch of x values that have,
There's a bunch of x values, like where?
like 2.
Like 2? Okay, so yeah, you're right. Here at 2, there's this ordered pair, there's this ordered pair.
2, 4, and 3.
Oh, 4 does.
3 does.
3 does. How about 2.5? Yeah, that one does. So it looks like any x value between what and what? 1 and 5. So this is a function?
It's not.
Not a function. Not a function. Each x value between 1 and 5 has 2 different y values. Take your pick. Any of those are culprits for breaking the function rule. Anything beyond 1, anything up to 5, any x value you choose has 2 different y values. So we're going to be that specific, okay? So any questions now before we move on? Thank you for catching that one. Okay, we are going to move on. I'm going to go to that last page. And it went too far. We'll go back. Okay, so express each relation as a table, as a graph, as a mapping diagram. And we're going to do it the way we talked about on the first page. Least to greatest, but hear me carefully on tables. Hear me on tables. In tables, it's the x value that gets written from least to greatest. So the smallest x value is -2. The next smallest x value is -1. Oh, there's 2 ordered pairs that have a -1. We can have repeats in a table. Yes, a table shows all of the ordered pairs. And we have an x value of 3. Now, here's what you don't do. You do not put the y values from least to greatest. You have to keep their relationship. So -2 would be mapped to 5. So it stays with 5. -1, well, one of the y values is 1. The other one is -2. And when x is 3, y is 1. So only the x's get put from least to greatest. Yes, Anne?
So if it has the same x value, it doesn't matter which one for the y.
No, then it doesn't matter which one goes first. Okay? So now we're going to graph it, so I'm trusting that since you guys have been able to name ordered pairs for me, you can graph those 4 points. Go ahead and get those graphed. Right now, how are you feeling about this one? Do you think this relation is a function?
No,
Why not?
that's two, that's
At negative one, there's two.
Yeah, at -1 for x, there's 2 different y values, aren't there? And it shows it because we have 2 points aligned vertically. When we do our mapping diagram, now we don't get to see the ordered pair relationship until we do the actual mapping. So we start by putting the least x value to the greatest with no repeats. So we do not need to write our -1 twice. And then we write our x values from, our y values, from least to greatest. We do not need to repeat that y value of 1. And now we do our mapping. -2 maps to 5. -1 maps to 1. But -1 also maps to -2. There's our breakdown for being a function, isn't it? It's being mapped to 2 different y values, and 3 gets
1.
mapped to 1. Okay? Questions? Okay, let's do one more of these then. Go ahead, fill in the table, fill in the graph, fill in the mapping diagram. You got it. How do you feel about this one? Is this one a function?
yeah.
Yeah. Do we have any vertical alignment going on in our graph? Any points above and below each other? No? Horizontal doesn't matter, but vertical does. Do we have any x values in our map diagram that have more than one arrow coming out from them? No. Doesn't matter that they all want 3. It's okay that they all want 3. They each only have 1. Each of those x values only has 1 y value. They just all happen to have the same y value, but who cares? It's still a function. So questions on that one? Okay, let's go down to the bottom then and let's work with domain and range one more time and being able to determine if our relation is a function or not. So, domain and range for this one. Can we make a list of x values? No way. It's what kind of a graph?
Constant.
Not constant. Continuous. It's continuous. Endpoints what? 0, 0, and 4, 4. Thanks, Eeyore. Okay. So what's the domain going to be?
Less than or equal to x, which is,
Less than or equal to 4. Okay, everybody write the range now. What's the range? Write it on your papers. What is the range?
The same as the
Oh, it just so happens to look the same. Oh, sorry, should write just the same thing again?
No,
with a y.
Oh, slow down here. Do what? Replace the x with a y because the range is showing the y values. Okay, is this a function?
Yes.
How do you know?
each x value only has 1.
Yeah, each x value only has 1 y value. Do we ever have any points on that line segment that there's a point above or below it? No, this is a function. Oh, so we can just say yes there since that line says function, I guess. So function, yes. And we would say each x value has only one y value. We don't even have to name them. If we can say each x value has only one y value, we're supporting that it is a function because that's the rule to make a function. Okay, how about the domain for number 4? What's the domain? 8 and 9. We always, in our mapping diagram, we always give the x values first. This first one will always be your x values mapped to your y values. It'll always be like that. What's the range?
-9, -6, -4, -3.
Yeah, they don't have those in the order we would put them, so we have to get them from least to greatest. And the next question, is this a function? Why not?
Each x value has more than one.
Yeah, each x value. We only have 2 x values, and both of them have more than one y value. So we would say each x value has more than one.
When it's not each x value, do you want us to specify which one it is?
Yeah. Yeah, and then, yeah, if it isn't all of them, then just pick one that breaks the rule. Say, x value so-and-so has 2 different y values, or has 3 different y values, or whatever. So here, because both x's broke the rule, we could say each x value has more than one y value. 8 has how many? 3. 9 has 2. How many ordered pairs are in this relation? 5. There are 3 ordered pairs with x values of 8. There are 2 ordered pairs with x values of 9. So if they ask you to write the ordered pairs, you should be able to do that also. Okay, what's the domain of number 5?
0, 1,
Okay. Do we need to repeat the 1? 2?
2.
No, don't. Range?
4, 5, 6, 7.
Just the way they're given, huh? 4, 5, 6, 7, 8. Again, can we now any longer see the relationship between the x's and the y's once they're written in domain? And if that table wasn't there and all they gave us was the domain and range, would we be able to write the ordered pairs?
No.
No, we can't. Okay, is this a function? No, okay. Why not?
X values 1 and 2 have more than one y value.
Okay, we got that issue. When x is 1, we have 2 different y values. Or you could pick on which other one? 2. You could say, you could pick on that one. So you get to pick
both of them?
No. So x value 1 has 2 different y values. If you would rather pick on 2 and say, no, 2's the rule breaker, you can pick that one.
So we can't pick both of them?
You can pick both of them. I'm just, I know how you guys like to save work. Okay, questions? Domain and range, relation, is it a function or not? You got it down? Okay, leave those out for me to stamp, and then here's what I'm going to do. I'm going to put, anybody not done, can I stop this?